Unit 6, Lesson 1, Similar Polygons. Similar polygons is something you have dealt with before, so we're going to go through and talk about them again. What are similar polygons? Before we do that, Part 1, review. Solve. This was from the half sheet that I gave you guys on test day. This one here, do you guys remember this one? This one we are turning in on Friday with the other packets as well. So this one here is what I'm going to review really quick. X over 4 equals 13 over 52. When you guys were doing this on test day on Tuesday, a few of you as I walked around were doing it different ways, which is perfectly fine, but I'm going to remind you of the way that you most likely learned around 6th, 7th grade. What is this process called? Cross multiply. What's x times 52? Equals 4 times 13. Can you calculate that in your head, by hand, or on your calculators? What is it? 52. All right, I'm trying to get x by itself, so what do I divide both sides by? That crosses out there, leaving me with x, and x equals 0 or 1. This reduces to a 1, so x equals 1. Questions? Okay. Number 2, x over 2x plus 1 equals 16 over 40. Is this another one where we can cross multiply? Yes, yes it is. Okay, so I multiply this way. What does that give me? 40x equals. Now when I multiply this way, there's a math word I'm looking for, something special I'm going to have to do that I haven't done yet. Starts with the D. Distribute. So I'm going to write it like this: 16 parentheses 2x plus 1 close parentheses. Why? Because it's not just 16 times 2x, it's 16 times this whole chunk here, the whole polynomial. So 16 parentheses 2x plus 1. And you guys said what was the word we're going to use? Distribute. Okay, so let's do that. 40x equals, what's 16 times 2x? 32x plus, what's 16 times 1? Times. Did I say plus? Sorry, 16 times 1. Okay. All right, what did you guys get for x? X equals 2. Make sense? All right. Another reminder, I did ask you guys to put these away, so make sure that you don't have them out. I want to quickly go over one with you guys from your worksheet. So right now you're just watching and you're going to check and ask yourself, did I do it that way when I did it on my own? And if you did not, you're going to go back and fix it tonight because we're turning this in tomorrow. So I'm going to look at number 10 from this worksheet that I handed out to you guys on Tuesday. Okay, can we cross multiply on this one as well? Yes, so I'm going to distribute 10 times the quantity of m plus 6 equals, and what am I going to distribute when I multiply this way? The negative 5. Good. Negative 5 times the quantity of m plus 3. So do I have to distribute on each side for this problem? Yes? So I'm going to distribute here. That gives me 10m plus 60 or plus 6 equals negative 5 times m is negative 5m. And I'm multiplying here. 5 times 3 is 15. Positive or negative? Negative, because a negative times a positive is a negative. All right, what would be the best thing to do as far as moving my m's around? At the 5m. Not the only way, but that works. Gone. And 10m plus 5m is 15m plus 60 equals negative 15. And what do I do here? It's tempting to add the 15. But if I add the 15, what am I going to end up with on this side? 0. And I don't want to do that. So what should I subtract instead? 60. Now I do have quite a few kids that are messing up here. 15m equals. They're writing this, they're not sure how to work it out. When you're subtracting, you add the opposite and you're adding two negatives together. So it's not 60 take away 15. You're going to add the 60 with the 15, and what do you get? Good. I heard a few of you say the negative. Is it negative? Is it supposed to be negative? So what mistake is being made when a kid says, because I often have kids say this, two negatives make a positive. So why is it negative 75? Can you tell me what the mistake is? Anyone? What is that? Who said it? Good. You're not multiplying. When you're multiplying two negatives, it makes a positive. But if you're adding two negatives, it stays negative. All right, what's the next step? 15m equals negative 75. What do I do to both sides? Divide by 15. And what does m equal? What is it? Negative 5. Put the answer in my answer spot. And then I look down here. Is negative 5 one of the possible answers? Yep, so I check it off so I know that I've used it. Got it? Did any of you guys do it this way when you did it on your own? Yes? Did anybody maybe have to go back and fix it? No. If you do, make sure you do it tonight before you turn it in tomorrow. Questions on number 10 from Tuesday's worksheet. All right, we are going to continue then with the lesson. Two similar polygons. Okay. Two polygons. Remember, a polygon could be a triangle, a rectangle, a hexagon, a decagon, all of those, pentagons, octagons, all of those are polygons. Two polygons are similar if corresponding angles are congruent. And I'm going to pause here. Two polygons are similar if corresponding angles are congruent. It's important to recognize that corresponding angles are congruent. And that is if they are similar. If two polygons are similar, is that the same as saying they are congruent? Is it the same as saying they are congruent? No, it is not. Okay, so how is it different? Well, this first part is the same. If two triangles are congruent, are corresponding angles congruent? Yeah, so far it's the same. And let's see how the rest of it changes. If the lengths of corresponding sides are, do you think the sides are going to be congruent as well? They can't be, because if angles are congruent and sides are congruent, what does that mean about the two polygons? They are congruent, and we're not talking about congruency, we're talking about similarities. So the corresponding sides are proportional. And that's the difference. The side lengths are not congruent, the side lengths are proportional. All right, so when polygons are similar, you have to remember corresponding angles are what? Congruent. And corresponding side lengths are proportional. You do have to know that for similarity. Questions? Okay, we're going to draw two polygons, quadrilaterals. I'm going to call this first one ABCD. A, B, C, D. I'm going to call this one G, H, I, J. Okay, so I'm going to tell you that these two polygons are similar. So we write our similarity statement like this. A, B, C, D is similar. That's your similarity statement right there. This tilde, this little curvy line here, means similar. A, B, C, D is similar to G, H, I, J. A, B, C, D is similar to G, H, I, J. Which means what about corresponding angles? Corresponding angles are going to be what? Congruent. So I'm going to write them here. Angle A, angle B, angle C, and angle D. Congruent to blank, congruent to blank, congruent to blank, and congruent to blank. All right. I want you guys to fill it in. I'll start you off. Angle A, you can see it in the image, and you can also see it actually right here in the statement. What angle does A match with? G. So I'm going to put one congruent marking there, and put angle G there. You go ahead and finish the rest. What is B matching with? What is C matching with? And what does D match with? And fill it in quickly, please. All right, do we have it? Yes. What is angle B congruent to? B is congruent to angle H, and you can see that there. B is second, H is second. What about C? I and D. J. Okay, questions on congruent angles? All right, our side lengths, our corresponding side lengths also congruent? No, they are what? Proportional. So we're going to write an extended proportion. An extended proportion looks like this. Let's write this down first. Extended proportion. All right, I'm going to start in order with this first one here. AB divided by what side length over here corresponds with the AB? The GH. So AB over GH. That's how I'm going to start it. Now, could I make markings like this? Don't write them in there. Can I put markings there like that? No, because that marking right there means what? congruent, and they are not congruent. Okay, so if I find the side length of AB and I find the side length of GH and I make a fraction and I reduce the fraction, it will equal BC over what corresponding side? HI. Which will equal CD over which side? The JI or IJ, and it doesn't matter if you put JI, that is perfectly fine as well. Okay, this last one, don't write it down. You guys are going to tell me if it is correct. I can then say that GJ over AD would work as well. That all of these are going to be equal. I did mess up. Where did I mess up? Anyone know? It should be what? It should be AD over GJ. Once you start left to right, you have to be consistent. So this last one here should be AD over GH. Not GH, sorry, over G what? J. Okay. Questions on extended proportions. If two polygons are similar, are all of these going to be equal? Yes, yes they are. If they're not equal, then that means that these are not similar. Okay, now I did left to right. You could have done right to left. You could have done GH over AB. Then what would this one look like? HI over BC and IJ over CD, and then this last one would have been GJ over AD. So if you flip one, you have to flip them all. Got it? Questions? Okay, we are going to move on to scale factor. Have you guys talked about scale factor in other math classes before? Yes or no? Middle school? Yes? Finding the scale factor. Okay, a scale factor is a ratio of corresponding sides. Scale factor is a ratio of corresponding sides. All right, so on this previous page, if I had numbers like say 3 and 5, and 3 over 5, 3/5 would be my scale factor. Got it? All right, so let's try this. I'm going to put here part A. Are the two polygons similar? What does that tilde right there mean again? Similar. Are the two polygons similar? Part B, if so, find the scale factor. And part C, complete the similarity statement. Okay, are we all ready? Number 1. Okay, I'm going to call this first one ABC. And I'm going to put angle markings 1 in A, 2 in B, and 3 in C. And then this one here, I'm going to put XYZ, and 1 in X, 2 in Y, and 3 in Z. Okay. I'm going to put here 6, 8, 10, 15, 20, 25. Okay, over here I'm going to put A blank, B SF equals blank. What does SF stand for? Scale factor. And C triangle ABC is similar to blank. Okay, so we already have angle markings in. I don't have to check that, but let's check our side lengths. Should corresponding side lengths be congruent or proportional? Proportional. Does everyone agree? All right. Now, this one is drawn in a way where they're not rotated. You can see the corresponding angles match up, so it's easy to match up their sides. For example, when I write 6, what would you put at the bottom? 15, 20, or 25? 15. Equals, when I write 8, what would you put at the bottom? 20 or 25? And when I write 10, what would you put at the bottom? Okay, so this one was pretty easy. When they're rotated, here's what you do. 6, 8, 10, small, medium, large. 15, 20, 25, small, medium, large. Do you guys see how that worked? Okay. All right, let's reduce them. I'm going to put an arrow here. What divides into 6 that also divides into 15? 3. What's 6 divided by 3? Over, what's 15 divided by 3? 5. Okay, we're going to check if it equals. Next fraction, it does not have to divide by 3. A different number is fine, but as long as it goes into the numerator and the denominator. What is it? 2. And you end up with 4. I'm sorry, not 4. 2 works, but what else goes into it besides 2? 4. What's 8 divided by 4? 2. And what's 20 divided by 4? 5. Okay, did that work? That doesn't mean it's done. We still have to check the last one. What divides into 10 that also divides into 25? 5. What's 10 divided by 5? And 25 divided by 5? Did they all work? Yes. So are they similar? Yes. Scale factor is the ratio of corresponding sides. Well, our ratio came up the same over and over. What is it? 2/5. Now, I didn't tell you which one to put first. Now, on the worksheet, it will tell you. If it ever does not, I want you to do left to right. If it doesn't specify, which I will specify in just a little bit, if it doesn't, you do left to right. Got it? Okay, scale factor is 2/5. ABC is similar to triangle what? XYZ. Questions? All right, number 2. Okay, does everyone have the image down? A blank, B SF equals blank, and C triangle QRS is similar to blank. All right. When I write the 9, what do I put in the denominator, 6 or 3? 6. Okay, and I asked that purposely. It's tempting to put 9 over 6 and 12 over 3, but has this triangle been rotated? Look at where this right angle is and look where this right angle is. Do you see that? Yes? So this one, if you rotate it around this way to make the right angle in the right corner, will your number switch around? What would go right here? If I rotated it this way. The 3, and what would go down here at the bottom? 6, this would be the T, that would be the V, and this would be the U. Okay, you don't have to physically rotate it, but you should at least recognize the size of your numbers. What's the smallest number over here? 9. What's the smallest number over here? 3. It's easier to see when you redraw it. If you don't want to redraw it, you do small with small. Equals, what's the larger number on my first triangle? Over, what's the larger number in my second triangle? 6. Okay, we're going to check if those two are equal. What goes into 9 that also goes into 3? 9 divided by 3? 3 divided by 3? 1. What goes into 12 that also goes into 6? 6. What's 12 divided by 6? What's 6 divided by 6? Did they come out to be equal? Are they proportional? Are they proportional? Side lengths have to be proportional. I asked the wrong question. Are they similar? These are not proportional. Are they similar? No. So these two we're going to put not similar. Not similar. Not similar. So pay attention when you're doing your work tonight that when the triangles are rotated, you either physically rotate them, redraw them, or just match small with small, medium with medium, large with large. Questions before I move on? Okay, number 3. Triangle NOP is similar to triangle WXY. Find the following. All right, let's draw the picture. Okay, NOP, WXY, and before I give you information, it tells you they're similar. Have the triangles been rotated? NOP, and then I go WXY. Has it been rotated? Yes, because this starts top left, NOP, and this one starts over on the far right, WXY. So it has been rotated. All right, so let's give information. NO is 6, OP is 4, angle O is 58 degrees, and angle N is 49 degrees. XY is 10. WY is 12, and that's all the information that will be given. So everyone get that down. 6, 4, 58, 49, 10, and 12. Question A. Find the scale factor. Find the scale factor of triangle NOP to triangle WXY. Okay, when they're specific like this, which they are, this number's at the top of your fraction, this number's at the bottom of your fraction. And I'm going to take a step back up here to number 1. Other ways to write this, typically I'd like you to write it as a fraction, but could you write it like this? 2 to 5 or 2 dot dot 5. Is that the same thing? Yes. We're going to write it like this in class. We're going to use it like this most of the time, but if you ever see it this way or want to write it that way, it is fine. Okay, so when they're specific on how to write it, which one goes first or at the top? The first one, and the denominator is the second one. All right. Now what we have to do is we can't just randomly pick small with small, medium. We can't just randomly throw numbers around. We have to read our similarity statement to see what matches. Okay, I'm going to try 6 first. What letters here do I have for the 6? N-O. Can you guys tell me what N-O matches with in the second triangle? Where is the W-X? Do I have a side labeled there? No. So can I use the 6 to find my scale factor? No. Next one is the 4. What letters can I use to describe the 4? OP are the last 2. What side does that correspond with in my second triangle? Okay, where's the XY? That's here, the 10. Do we have a matching side? 4 with the 10. All right, how did I figure that out? OP, XY. Okay, so what would I have? 10 over 4 or 4 over 10? 4 over 10, because it has to be NOP over WXY equals, what does that reduce to? 2 over 5, or 2 to 5, or 2 dot dot 5. Okay, so moving on, questions on part A. Part B, find the measure of angle X. X is here. Did they give me any numbers in this triangle at all? Yes or no? But what do we know about corresponding angles? They are what? Congruent. And what is X? Let's look at the position of X. What does X correspond with? O, and what is O? 58. So can we say that angle X is 58 degrees and be good and done with that part? Yes. Part B, find the measure of angle Y. I'm going to let you guys try that one now. The measure of angle Y. I do mean part C. Thank you very much. I love it when you guys are paying attention. Okay. Measure of angle Y. Find what angle Y matches with. All right, anybody have it? A volunteer? Yes. 49? Okay, let's check. Y corresponds with what letter? Okay, it's okay. I'll let you fix it. What is it? 73. Who's giving me that? Okay, can you explain why it is 73?
Because Y corresponds with P, and you have to find the missing number.
Okay, he said Y corresponds with P. We don't know P, so you have to find the missing angle. Did anybody do that? 49 plus 58 plus angle P equals 180. And when you do that and solve, do you end up with, what did you say it was? 73. Did anybody do that on their own? Good. And then angle P corresponds with Y, therefore Y is 73. Are we good? All right, last part, D and E. D, find NP. When it's written like this, what does that mean? NP without the bar at the top means find the length. Find the length of NP. All right, I'm going to come to my image. Does NP have a number here? Yes or no? No, I'm going to put a letter only. There was not a letter given. I'm just going to put a letter so that I can use it to make my equation. All right. I'm going to erase that equals. Okay, so let's make our fraction. A over, what does NP correspond with? NP corresponds with what? WY. Does WY have a side? WY is what? 12. A over 12, NP over 12, how did I know to jump from here to here? NP corresponds with WY. NP, WY. All right, equals, what can I set it equal to find the value of A? Of what? The 2/5, the scale factor, right there. All right, go ahead and cross multiply and solve. 5A equals 24, divide, you get a decimal. Go ahead and do that now. Go, write it down, plug it in. And what did we get? 4.8. So NP equals 4.8. Are we good? Okay. Letter E, find WX. Okay, here's WX. Does it have a number there? So I'm going to put a letter. I'm not going to use B only because 6 and B's, I don't want to get them mixed up, so I'm going to call it C. Okay, what side does XY correspond with? OP, which is what? Okay, I'm sorry, I said it wrong, and I apologize. You guys answered right, but I said it wrong. WX. WX corresponds with which one? NO, and where is the NO? NO has a what? 6. So it does make a difference. Should I put C over 6 since I'm looking for C, or 6 over C since that's the way I wrote my scale factor? 6 over C. However, this was specific on how to write it. This side over this side. So 6 over C. NO over C. Does that make sense? NOWX. NOWX equals, what was the scale factor? 2/5. Go ahead and cross multiply. That one does not come out to be a decimal. What do you guys get? 15. So the length of WX is 15. Questions? These are on the test. These are on today's assignment. Do you guys think you can handle them? Yeah? Okay, that's it for notes.